I am Guilherme Bodin, and today I'm going to present to you about automatic dualization with Dualization.jl. So, Dualization.jl was the result of a Google Summer of Code project entitled Jump Automatic Dualization. During the project, I was mentored by Benoit, Chris, and Joaquim. The project goal was to create an API on top of MathOpt interface, which is the base for Jump, MOI, to dualize conic optimization problems. Since the end of the GSOC development period, we managed to push some new features and extend the package to dualize up to conic quadratic problems. During the project, I got asked a lot by colleagues, why do we need Dualization.jl? So here I list some of the main reasons. Easily writing the dual problem has some motivations. With the prime and dual problem, we'd get close to writing the KKT conditions of an MOI problem automatically, so we can derive a dual problem programmatically. This speeds up a lot of the research process, and it takes out the burden of having to write and derive all the dual formulations for problems, and then input them in Jump manually. So having the KKT conditions automatically is very useful for extended mathematical programming, multiple optimization problems with complementarity constraints, and bilevel optimization, etc. This is one of the main reasons. We wanted to extend Jump to deal with all these different classes of optimization problems. Another reason is that some solvers can only represent specific formulation types. So in conic optimization, some solvers accept the standard form, and some other solvers accept the geometric form, which is explained a little bit more depth in the repository reading. So dualizing the problem can leave the representation closer to the form expected by the solver without adding slack variables and constraints. And this can potentially lead to a significant speed up in the optimization routines. The last reason is educational reasons. This can be useful for students learning about convex optimization. During the time that I was in the GSOC program, I was also a tutor in linear programming at PUC-Rio. And many students use Dualization.jl to easily derive and check if they got answers right in their assignments. The Dualization.jl package has a very simple API. It has only two main features: the dualize function that can receive either a MOI model or a Jump model and then dualize it. When it receives an MOI model, it creates a new object called dual problem that has the dual of the model provided and a map that relates the primal with dual. It links dual variable with primal constraints, dual constraints with primal variables, etc. And when it receives a Jump model, it returns a new Jump model with the dualized model inside. And if you provide an optimizer in your Jump model, it automatically attaches it to the dualized model. The second main feature is a dual optimizer. This is used for solving a primal problem using its dual representation. So the dual optimizer, the idea is that it solves an instance of the problem via its dual representation. So it dualizes the problem, solves, and then you can query the primal solutions of your primal problem via the dual solutions of the dual problem. It works like any other optimizer, but you have to provide inside, you have to pass an argument with an optimizer that actually has an algorithm to solve the problem. So here I wrote a small example of the API. So you pass a dual optimizer with an optimizer inside. It can be GLPK or SKP, really any optimizer that Jump accepts. So a quick walkthrough through the docs. I wrote the docs using Documentary.jl, and it has all the basic things. So I mean, a manual and some examples. So it has a little bit of the mathematical background. So what are we dualizing? What is the primal representation of a problem? What is the dual representation of the problem? it has all the supported constraints and supported objective functions. And it has a in more detailed manual about the two main features, which is the dualize function and the dual optimizer. Okay, and here we also have some examples for users to just copy and paste in their Julia session and experiment on the fly. Okay. So back to the presentation. Dualization is already used in bilevel jump. Bilevel jump is a package that allows users to write bilevel optimization problems with the usual jump syntax. And some methods to solve bilevel optimization are based on rewriting the problem using the KKT conditions of the lower level problem. For that, the package makes strong use of Dualization.jl. So in summary, the main goal of Dualization.jl is to remove the burden of having to write the dual problem by hand or by some module. Everything's already programmed and integrated with the entire jump stack with Dualization.jl. One of the nice things is that we only need to keep in mind that dualization needs to be compatible with some MOI versions, and everything should be okay. And this shows a little bit of the power of extensibility of the whole jump MOI framework. So thank you. Please don't hesitate to submitting issues and telling me or any other developer about suggestions. And a special thanks to the Jump Dev team, my mentors, and other developers that helped me along the way. Thank you very much.